Good morning. In this video session, we're going to discuss about what is the transition diagram, how to draw a transition diagram. In the last video, what we have discussed is parsing and ambiguity of parsing, and before that we have discussed phase of compiler and introduction of compiler. Today's session we're going to discuss the transition diagram. First, initially diagram, you know what is the diagram is. It's a representation of a graphical representation using pencil. We'll draw a diagram circle like this, something we'll creatively draw, no, that is called as diagram. It's a representation of drawing something and to communicate with others. So here the transition diagram is nothing but it's have a collection of node of circles with start state. Start state is mentioned with arrow mark and end state is mentioned with double circle. Here the communication is like from which state to which state the arrow passes and what is the value, input value from that state. That is the notation of transition diagram. Each state represent a condition that could occur during the process of scanning the input, looking for a lexeme that matches one of several pattern. If it is matched, it will execute that. Edges are directed from one state of transition diagram to another state. Each edge is labeled by a symbol or a set of symbol that is called as edges. Here the number of nodes are called circled and start state is with arrow mark and end state is with double circle, and the edges are directed from one state of transition diagram to another state. Each edges is labeled by a symbol of set of symbols. If we are in one state, yes, and the next input symbol is we are looking for an edge out of the state labeled by A. If we find such a edge, we advance the forward pointer and enter the state of transition diagram to which each edge lead. So some important conventions about transition diagram are: the first point is certain states are said to be accepting or final. These states are indicate that lexeme has been found, although the actual lexeme may not consist of all position between the lexeme beginning and forward pointer. We always indicate the accepting state by a double circle. So what I mentioned is starting state with mentioned with the single arrow mark, double state mentioned with a double circle. If necessary to return forward pointer one position, we shall additionally place the asterisk. So asterisk means we'll forward one pointer by accepting that state. One state is design the state or initial state. It is indicated by the edge label start. We'll write there arrow mark start. That is mentioned as start symbol. The transition diagram always begins with the state before any input symbol have been used. The starting state, before any input symbol, we should have some starting state to start the transition diagram. So the example for relational operator, the transition diagram is given. Less than or equal to. Start the program. If you circle 0, the 0 state will move to 1 when it is less than. Next to 1 to 2 when it is equal. That condition is return the reloop less than or equal to. If the input symbol is less than or equal to, it will go to the state 2. If it is greater than, it will go to 3. If it is other relational operator lesser than, it will go to state 4. If it is 5 means it's equal to. If it is greater than means it is greater than equal to means it is 7. Other than that, other options means it will go to 8. So this is the state diagram to represent the relational operator. One more example is given for the transition diagram for the identifier. What is identifier? First letters or digits. Letter should start with alphabets A to Z. Digits should start with 0 to 9. The start symbol represent the state 9. That start symbol means the starting arrow, that 9 state. If it is letter means it will go to 10. In that state, if you are getting letter and digit, it will keep on moving in that same state. So the self state 10 itself, it will move until you are getting other than that letter and digit. It will not move to any other state. It will stay in 10. If once you are getting not a letter, not a digit, any symbol you are getting means it will go to 11th state. Okay, so this is a transition diagram for letter and digit. Next we're going to see how to convert regular expression to NFA. So here the one of the way to convert regular expression to NFA, The other way is much convention is here the Thomson construction method. We're going to discuss the Thomson construction method. We have one initial state and one final state, one start symbol. We can represent the start symbol with simplest part alphabet symbol. To create a NFA for a complex regular expression, sub expression, we'll use the Thomson construction method. For a empty string, this is a representation, epsilon. To recognize an alphabet, I state goes to F, final state. If the input is A, means A. We are expressing R1 slash R2. So if it is from this state, it will go to R1 and R2, two options. So epsilon, epsilon, R1, R2, epsilon, epsilon. This is the represent of Thomson construction method. R1 dot R2. So it's in the parallel R1 dot R2. Then it's for asterisk, R asterisk. So R asterisk, you have a symbol R, epsilon, R, epsilon. If it is asterisk, means it is self loop, and from start to end one more. That is representation of R asterisk. This is the rule for Thomson construction method. For a given expression A slash B whole asterisk, we are drawing a NFA construction. We are converting this regular expression into non-finite automata using Thomson construction method. First A. A means directly you can write a start symbol A, double. B means you can write B cells. Second, you have to write A slash B. A slash B means parallel. So epsilon A, B, epsilon, epsilon. For that, whole asterisk means you should draw one epsilon here and one epsilon here. Correct? Then you have an input into A. So finally, after completing the A slash B asterisk, this part, we are writing one more input A and then double circle. Double circle means it reaches the final state. So today's class, what we have discussed is what is regular expression, how to construct a regular expression to NFA using Thomson construction method, how to draw a transition diagram. So we learned the start symbol, what is the final state representation symbol, what is edges, what is node, how the diagram is drawn, how the regular expression is created to NFA using Thomson construction method. I hope you understand very clearly. Thank you for listening. Today's class is about transition diagram. Thank you.